We're going to begin combining inequalities now, and we have two different kinds of inequalities. We're going to be discussing first the condition where both inequalities must be true, as in both sets of numbers that make one true must make the other one true at the same time. So we're going to begin with that. So with our first example, we're going to be talking about x less than 2 or x greater than or equal to negative 5. So the first thing that I like to do here is begin with a number line and put my two numbers on it. And as we learned before, whenever we have an equality, like the negative 5 one, we're going to use a solid dot. And we're going to have an open circle here for the 2. Now what we're looking for are for numbers that are both less than 2, so I'm going to draw a little line this way, and greater than or equal to negative 5. Well, if we go beyond negative 5, we're no longer greater than or equal to negative 5. And from the negative 5 end, if we go past 2, we're no longer less than 2. So what this means is that the solution to these two inequalities together is this line in between negative 5 and 2. And we can rewrite this as negative 5 less than or equal to x less than 2. And in interval notation, it would be bracket negative 5 to parentheses, as we learned earlier. Now let's try another one. We're going to be changing the direction of the inequalities and see what happens here. So for example 2, we are going to put a number line down again. And mark our two numbers. They're the same two numbers. A solid dot over negative 5 and open over 2. So this time it says x greater than 2. So we're going this direction. Now, if we choose to try to fill in the middle here, that's not greater than 2, and that does not satisfy the AND requirement. So we're going to not to do that. So the only part of our number line that is both greater than 2 and greater than negative 5 is right here. So really, the x greater than 2 satisfies both of those conditions. Putting this into interval notation, we begin with 2, and we're going to go up to infinity. Okay, so once again, we're going to change a condition on our problem here. Switch a direction of an inequality around. And because it says and, both have to be true. So I'm going to put my solid dot, my open circle. And so it says x less than 2 and less than or equal to 5. Well, this section right here, that's less than 2, that's not less than or equal to negative 5. So we're not going to use that part. So as we said, since it has to be less than both of them, we can't use the section that's between negative 5 and 2. We're only going to be able to use this end. So this is going to be our inequality that's true for both of them. And if we do interval notation, we'll set it up like this, and because it is an equality, it has an equal, we're going to be putting a bracket. Now for the last change of condition, I'm going to, again, mark my spots here. Put a solid here, open here, and it says x greater than 2, so I'm going to point it that direction and x less than or equal to 5. Well, there's no single number that is true for either one of those, so we can't do that. So I'm going to erase that. So there's no number that is both greater than 2 and less than or equal to 5. So this is no solution. Now when we see the word or used, that is an option. Only one condition must be true, and as long as one condition is true, then we can write our solution set. So let's start with example 5, and it's much less restrictive, or is, because you have a lot more options. So again, my number line, very conveniently, same numbers every time. Now it says x greater than 2, or x less than or equal to negative 5. Well, since it doesn't have to satisfy both of them like the same condition with the and, we can use this. But there's this huge gap in the middle, so we're going to have separate intervals, negative infinity to negative 5, bracket, and then parentheses 2 to infinity. What we need for a complete answer is a union of the two sets, so we're going to put a U there to show that the two sets are unified. So we're going to go through the same exercises we did before and just change the conditions on this and see what happens to these. Oops, that's an open. Okay, x greater than 2, this way. X greater than or equal to negative 5, that's also that way. Now this whole issue with the open circle at 2 can be a solution because it's greater than or equal to negative 5. So we're just going to shoot straight through it and close up that hole right there. Now our interval begins at negative 5 and goes all the way to infinity. So now this is our inequality. If it was an and, we would have to use the other one. Okay, so I went ahead and filled in the number line for us. So again, remember, this is a whole lot less restrictive. So I have x less than 2, and I just went through the negative 5 because it's part of that, or x less than or equal to negative 5. Well, that's already part of the answer, don't you think? So the ors opens up our possibilities. So really, the inequality that we're referring to is this, x less than 2, and we're going to begin at negative infinity. Read your interval notation like you read a book. You're going to read it from left to right. And we shot straight through that negative 5, and we're going to go all the way up to 2. Okay, so last one with changing all the conditions. So x less than 2 takes us this way. Or x greater than or equal to negative 5 takes us this way, and it shoots straight through that 2. So really, that open circle can be taken out because you're going to go straight through it because 2 is an answer because it is greater than or equal to negative 5. Remember, only one has to be true. In this case, our interval goes from negative infinity all the way to infinity. In other words, all real numbers will be our answer. Okay, so let's go through a few examples. So we're going to start with example 9. And what you see is that we have two sets of inequalities. Right here, 1, 2. So the way that we're going to solve this is just like an equation. But what happens, the middle is what determines what happens. So what happens in the middle has to happen on the ends. So we're going to subtract 5 everywhere. And then we'll divide 2 everywhere. And I want us to graph it. And this is an and, because x is between two other numbers. So we've got -1 and 5. Open circle, close circle. And we're going to connect them. And as an interval, -1 to 5. And 5 has a bracket because it has an equal with it. Alright, so before we can go to the number line, we still have to graph this, and remember, whatever we do in the middle has to happen on both ends. So in the middle, I've got a 4, so I'm going to subtract that 4 everywhere. And I'm going to have 8 greater than or equal to -4x greater than -8. Okay, so I have a -4 multiplied by x, and when I divide by a negative, what happens to my signs? It changes the direction of my inequalities, because everything's opposite. So now I have -2 less than or equal to x, which is now less than 2. Alright, so now we have this. This is also an and, because it's a between problem. So we're going to do this. And we have a -2 here, +2 here. The equal sign tells me the -2 is solid, and the +2 is not. And then we just connect these. So we will do a bracket on the equal end, and a parentheses on the not equal end. Now I did something silly, and this sheet has 10 and 11 are the same exercise. So we're going to skip that one and go directly to example 12. Okay, this one is an OR problem. How do we know it? Well, for one thing, it tells us it's an OR problem. Or at least we think it's an OR. So we're going to see. So we're going to solve these two inequalities separately. So the first one on the left, I'm going to subtract 7 on both sides. So that gives me -6. And then I'm dividing by a -2, so that changes my direction and my signs. Okay, so that's one part of it. The other part of it, I'm going to subtract 10. And then I'm going to add y. And then I'm going to divide 4. Okay, so let's see what happens on our number line when we graph this OR. So we've got -3 halves right here. And we've got +3 on this other end. So -3 halves, open circle, goes that way. And +3 is a closed circle, and it's greater than, so it's going to go right. So it really is an OR problem. There's a big gap in the middle, so that's where our U goes. That is part of our interval notation. Arrows go with infinities, and infinities go with parentheses, and open circles also go with parentheses, but closed circles go with brackets. And then on this other end, I have another infinity. So it is important to write your intervals in the order from which they start, moving left to right or least to greatest. Don't put infinities towards the middle of the unions. They need to go on the ends. And that ends our lesson on inequalities.